Another thing you could do is that we're already producing all this concrete, which you can sequester a big portion back into the building material we're using. So it's a product that is in the market. It's just not widely available, where you can have concrete that is a carbon sink. All of the carbon that was created in the production was sequestered and then stored and put back into the concrete. So you actually have a carbon sink, which is pretty incredible.
When you think about like where we are now, back to this, we've had the same mix since the 1700s. Are there areas of innovation, things you say, oh, I think that we can rethink things? I mean, it just seems like there's opportunities for innovation.
Yeah, I think so. We've tried using different materials to substitute out the cement, which has been really, fun and interesting to watch. Things like rice husk, burning rice husk. There's like another one that is accepted in most of the world it's called fly ash, which is the byproduct of burning coal. And so these things can be used up to like 30 to 40% replace cement. The thing that's beneficial with this is it doesn't have that off gassing that what I mentioned, the 70% of the CO2 that's produced. You skip that whole thing by replacing it with this other material. What we've realized is that these other materials don't just have the less CO2 benefits, but they also have other properties. They can cure faster. You potentially can get more strength. There's likely going to be more and more innovation in various types of concrete that is produced based on different applications. And we already do have this. We have different, certifications based on if it's an interior wall or an exterior wall, if it's load bearing or if it's flat work. There is the potential for even better refinement so that we can build things like, for instance, if you're going to build a factory and you're going to build buildings in a modular fashion, in like a highly mechanized way, in a factory, you want very different properties. Like you want this to cure as fast as possible. And you're in a controlled environment where you're not out in the elements where it could be freezing or cold and you have to deal with raining, whatever. So like in a controlled environment, you don't need to build to the lowest common denominator of like what works in any scenario. You want to find the best product that works in this particular environment. And that innovation starting to happen now. There has been huge investments. Norway set these like super high environmental efficiency standards from their equivalent of the EPA and put for all kind of industries. In order for them to reach their target, they've invested like 1.8 billion euros to building out a carbon capture plant on one of their cement plants. And that alone is going to have, I think it's high single-digit percentage change in their whole country's emissions just based on being able to capture some CO2 from this plant.
So it's basically ingesting carbon and then using it for, basically putting it into the concrete mix.
Exactly. Yeah. Bill Gates, this is like one of the things that he's most excited about. He's been pumping a lot of money into cement, at least a half a dozen, maybe a dozen companies that are helping to decarbonize and provide innovation in this sector. So like he's invested in one, which is doing exactly what you're talking about, which is like air capture, carbon capture. And there's another company out of Canada that is actually able to sequester this carbon back into the concrete. So like it's likely the only way that we're going to be able to hit the Paris Climate Accord objectives of how much CO2 we need to reduce. The only way we're going to do that, I believe, is through carbon capture. But you need to figure out what do you do with this stuff. Like once you get pure carbon, where do you put it? A big solution has been to essentially sequester it underground in bedrock, which is doable, but it's expensive and it's complicated and requires a lot of machinery.
Given how abundant this substance is, and that can make, it's going to take all these different types of innovations to really, I think, move the needle. One of the things we were talking about earlier too was just, what are different ways to leverage what we have to potentially create like feedstock for concrete? And one of the stats we found, I think was interesting, was 25% of demolition debris is actually diverted today from landfills or reused or recycled, according to the EPA. I was actually impressed it was that high, to be honest. That still means 75% of it all is ending up in landfills or somewhere out there. And so I still think a lot of opportunity there when you think of the waste stream in our country. Part of the challenge is everything just kind of comes into these, into recycling centers and waste management. And then it's, well, how do we isolate all these different things? And there's some really cool companies. There's one company called Glacier that I interviewed recently that do AI recycling robots. And so they're able to look very quickly as all these different materials come in and isolate the different materials and start to say, okay, this one is this type of plastic, we're gonna put it here. This is glass, we'll put it here. And so, I'm not close enough to this to know, like, can we is there a whole waste stream there that becomes feedstock potentially for concrete? You know, you already have this abundant waste stream in our country that ideally it's already local. You can just tap into it. But I think historically part of the challenge has been, is the juice worth the squeeze, right? Are we spending more time and resources trying to extract this than it's actually worth?
I think you're right. It's like, we have so much of the waste that we produce is coming from these building materials that like you certainly can reuse a lot of it. The problem is that in a lot of areas, recycling, when you actually really do the accounting of how much energy it takes to sort it, separate it, identify it, break it down, reuse it, and produce the material, you end up with more energy used in that process than just getting the natural resource and building it in the first place. But I think that at some point, we're going to be able to do this cheaper. Maybe it's through robots, and Wally can be running around in our trash and figuring out how we can separate all the different metals and materials.
I think this is where government just, again, needs to be more involved, but government needs to kind of wake up. And I always think the challenge is they're just, they're 4-year cycles in most cases, or, they're pretty short. And I think to really drive systemic change here, you have to think on the on lines of decades. You have to think, okay, I'm going to do this 20 years from now. What are we going to start to do today?
There actually is a few companies that I've come across and have been trying to figure out if we can use it in our business, but that they do use recycled materials for 3D printing. And there's some cool stuff that you can do with this where they're using like recycled. It can be really, and you think about the big innovation that Elon Musk had with the Boring Company. Like his biggest innovation wasn't the drill that he made. It was the fact that the biggest cost that he realized you have when building a tunnel is you need to figure out what the heck you're going to do with all that dirt. Yeah. That's a bunch of volume of stuff. And the only thing he did is he found a little, made a brick maker, basically stacked the bricks and said, hey, anybody want bricks? Here's free bricks.
Yeah. Well, and that's what I go back to. You have to look at problems that have been around forever, and you just have to apply a different lens through them. And some things don't work, but in the case of the Boring Company, it was exactly it. I'm going to remove half the cost, and I'm just going to make bricks on site, and people can take them away from me. Freaking genius! Everyone's probably standing there like, why didn't we think about this for the last 100 years?
And that just makes sense. Like, you're removing a cost center from one business, and then you're removing a cost center from another business, or potentially making it a revenue center for one of them. And like, that just makes sense like that. And I think that, to your point, is like, it's been a logistics problem. We haven't thought about things this way. And so it's not just like doing it for environmental reasons, but it's like, this is like good business practice. Like, find cheaper materials that have the same properties or potentially better properties for what you need to do. I think it's just going to require kind of a rethinking of the supply chain of the materials we use.